Hello everybody and welcome to this printed hybrid in mould and 3D electronics event. My name is Chris Clare and I'm the event director here at TechBlick. It's my absolute pleasure to introduce our first presentation of the day, which is from Dr. Manabu Ito from Toppan, who's going to give us a presentation on highly bendable inorganic TFT array for sensor applications. As always, we will be taking your questions live at the end of this presentation. So please leave any questions you have in the sidebar and we will take them at the end of this talk. I'm now going to hand over to Manabu and I will be back at the end of the talk. Over to you.
Okay, thank you, Chris. And hello, everyone. My name is Manabu Ito of Toppan Inc. First, thank you very much for inviting me for such a prestigious event. It's a great honor for me. So today, I want to talk about the highly bendable inorganic TFT array for sensor applications. But before starting my talk, let me briefly explain what our company is, Toppan. Toppan started in 1900 as a printing company. Now, Toppan has three business domains in our business. One is information and communication, living in an industry, and electronics. And in the center of the three business domains, we have printing technologies, which consists of information processing, microfabrication, surface treatment, material forming, and so on. So, okay, let's go on to my today's topics, flexible devices. As you all know, flexible displays and flexible sensors have been attracting much attention recently. And here, I show you some of the examples. And these examples are listed upon the demanded bending radius from low flexible to medium flexible, which is usually used for the foldable smartphone, and highly flexible one, which can be mainly used for flexible sensors. And in flexible sensor applications, high flexibility is required to fit into the human body or three-dimensional objects. Our target is in this region. Therefore, TFT should withstand the bending radius of around 1 millimeter and a number of bending cycles. Up to now, numerous work has been devoted to make flexible TFTs. Here I categorize the proposed methods for realizing flexible TFT from material, TFT design, and to entire device structure. And as for material, using soft organic material is one of the promising way to make bendable devices. I think you can instinctively understand that the soft layers can be easily bent. On the contrary, hard, brittle materials are hard to bend. As for TFT design, employing island structure concept is preferably used. In this method, stiff inorganic layers are patterned into island structure on a compliant soft substrate. And if you bend this device, soft substrate beneath the islands flow during the deformation. Therefore, strain in the stiff inorganic island can be reduced. In this manner, hard brittle materials can be employed for flexible TFT. And as for engineering entire device structure, there are two methods. First one is thinning total thickness. Total thickness of the device is normally governed by the thickness of the substrate. So, therefore, thinner the substrate is, smaller the strain is. Second one is the utilizing neutral plane concept. If you bend a sheet-like structure, outer surface is in the tensile stress, is under tensile stress, and the inner surface is in the compressive stress.